Please fill all of this in. You can talk to your neighbor about it if you don't think you can handle it. Fill everything in on the left. So how long did the DV and the IV first. What's the DV? DV, we have depth, which would make the IV time. Is he right? Of course he's right, because the depth of a dive depends on how long you were in the water. Right? Am I scuba diving right now? Of course not. So do I have any depth below the water? Of course not. But time is still passing for me. Well done. How many minutes did the dive last? 30 minutes. Absolutely correct. At what times did the diver stop her descent? This is a tricky one.
48 minutes and 10 to 14.
Right. She stopped twice. 4 to 8 minutes and 10 to 14 minutes. How did you know that?
She didn't dive.
Right. Because time carried on, but her depth did not change. So here, maybe she saw an octopus. Here, maybe she saw Nemo. Who knows? Everybody good? Spectacular. How many of you, until you got to question 3, thought that the scuba diver was a man? Oh, good. I'm glad none of you did. What was the greatest depth?
20.
Anyone, I don't care. 20 meters. For how long did she spend at this depth?
4 minutes.
4 minutes. And lastly, the domain and range. What is the domain? We just did 12 of these. What is the domain? Because according to all of your tests, you all got 20 out of 24 on this. So every single one of you can find domain. So what is the domain? Or you're all lying on your tests. Because I'm willing to give 0 out of 24 to everybody unless somebody can answer this question for me. Because if you can't answer this easy one, obviously you couldn't answer the difficult ones on the assignment that you marked. So I'll just wait for a couple moments before I decide that nobody's getting anything on the assignments. Fortunately, I have lots of coffee and lots of time. Sahaj.
0, 4, 8, 12, 16, 20,
You're close. And you get credit for attempting it. Anybody else? Rajan.
0, 4, 8, 12, 16, 20.
Nope. You're close. And you get credit for trying. Nadaline. 0 to 30. You're halfway there now. What's missing? What's missing from her answer? Because right now she's telling me 0:30. She is giving me the point on a graph somewhere up around here at 0:30, which is not what I am asking. What does she need to finish that off? Pardon? Yes, the hard brackets. You could also, of course, have had 0 less than or equal to time, less than or equal to 30. What was the range? Zero 20 or less than depth, less than or equal to 20. Excellent. All of you should have been able to do that all by yourself without any talking from me. The only thing here that you required some thought about was this one. At what times did the diver stop her descent? There and there, there and there. And it doesn't show up very well on the gray, but that is because time never stops. Time keeps changing, but her depth did not. All right? Now, you are intelligent young people. You notice this much white space. You know there's stuff happening here. Describe to me what is happening in this green section of the graph. In English, using words, what is happening there? Somebody explain to me what is going on. Tell me a story. All of you were able to read the graph, unless you're lying to me. So all of you can tell me what is happening in the course of the first 4 minutes. All I want to know is what's happening. I'll give you an example. The teacher stood up. That is the type of sentence I'm looking for right now. What happens in the first 4 minutes? Jaginder.
She dived 12 meters in 4 minutes.
She dove into the water and swam downwards. Would get you 1 out of 4. Right? Now, Jaginder went to 2.5-ish out of 4 because he added that she dove 12 meters down in 4 minutes. How did you know that, Jaginder?
That's where she stopped.
Right, because that's where she took a break. She went 12 meters in 4 minutes. And all of you will, of course, notice that that line covered 12 meters of dependent variable in 4 meters of independent variable, making this fun triangle. That fun triangle, as Jaginder said, she went 12 meters in 4 minutes. That is what we call a rate of change. Now, I said Jaginder did not quite get 4 out of 4. Can anybody guess why Jaginder did not get 4 out of 4? Madeline. Didn't say. No, not quite. Do we ever have other rates of change in our lives? Ever in our lives do we go some distance in a period of time? When? All of you are trying to get your N. Pardon? When you're driving. How do we measure our rate of change when we're driving, Kush? What's the speed limit by a school? 30 what? 30 kilometers isn't a speed. 30 kilometers is a distance. 30 kilometers what? Per hour. So when we are going to do a rate of change, we always have the one we know of, kilometers per hour. Right? Per how many hours? 1. We don't say the speed around a school is 60 kilometers per 2 hours, do we? No, that would be stupid. We always do it in units, right? Now, you're intelligent young people. This is meters and minutes, right? Meters being a distance and being our dv. Time in minutes being a time, but it's our IV. So a rate of change, since now twice it has happened, distance over time, can we write that as dv over IV? But not quite, because it's the change in dv, and that's what that little triangle means. You'll see it a lot in physics. That little triangle means change. So, again, I said Jaginder is almost to the perfect answer. How could he make this perfect? Because you wouldn't say, I ran 12 meters in 4 minutes. What would you say? We don't want it over 4. What do we want it? over 1. So we don't want 12 over 4. What we really want is something over 1. We don't know what that is, so we make it an x. Now, of course, we do know what it is because 12 divides by 4 perfectly. But if it didn't, we would have to do algebra here. So what is the proper answer? She descends at 3 meters per minute. Right? Everybody agree? Okay. When is the next time she does some descent? Right here, yeah? So what is that one? What is the change in her dV? How far deeper does she go? She goes from 12 to 20. So she went, and I'll do this one in blue because I shaded it in blue. She went 8 meters in how many minutes? From 8 to 10 is how many minutes? 2 minutes. Is that the rate that gets us the A? Is that 4 out of 4? Why not? It's got to be over 1. Now again, does this one work out perfectly? So we can just do division because we know it's going to be 4. So her rate here is 4 meters per minute. Right? Which is faster? The red or the blue? Which, Rajan? Blue is faster, yes? So please notice that blue is a higher rate of change, and it got us a steeper line. Why is it steeper? Because she is using more IV in less DV. Everybody understands? Okay, is there another spot where there is a rate of change here? When she goes back up, right? Oh, that's a horrible color. That's not working at all. Right there, yes? And what is that rate of change? What's the IV part of it, which I will do in green? What is this part? 20 in how many minutes? 12? 14 to 30. 16. Is that the right answer? Is it a right answer? Is it the best answer? How do we make it the best answer? Over 1. Does this divide perfectly? No, so I actually got to do the math, right? 20 times 1 is 20. 20 divided by 16 is what? One point. So she went 1.25 meters per minute. And notice it is the least sloped, right? That is less steep than the other two. Is everybody cool? We'll talk about why one leans this way and one leans that way later, but that's where we're at right now. Everybody understands what rate of change is, yes? Okay. Let's go on to the second question. This is a graph of a real-life situation. You tell me what this graph means. Go. Write what you think in words in this section over here. Remember, this is the type of question that I would give you a 1, 2, 3, or a 4 on. Try to get the 4. Go. Go. Who has a story for me? Or do you want to hear the real story? That's what happened. That definition, that story, would get me 3 out of 4. Why doesn't it get me 4 out of 4? What's the only thing I could add to get 4 out of 4? The rates, right? How long did it take to fill it? Well, I filled it from 1 to 1.75, right? So 0.75 of a liter in 30 seconds, right? What would be a sensible way to write that properly? Most of you are going to say how many liters in a second, right? Because you want this to be 1. I, of course, would make it 1 minute, which is 2 of these, right? So what do I got to do to this? Multiply by 2. So I filled it at a rate of 1.5 liters per minute. Then I dumped it at what rate? How much water came out of the watering can? 1.75 liters in how long? 20 seconds. What's the sensible rate there? Madeline. No, because I started at 1. I only added 0.75. It was half full. So what do I do here? What's the sensible rate to use? 1 minute, right? What did I have to do to 20 seconds to get to 1 minute? Times by 3. So I would multiply this by 3 to get 5.25. 5.25. She was not happy with this scenario. But that's what big brothers do. Am I right, big brothers? What is the point of having a little sister or a little brother if you can't mess with them? They ruined your life, right? Until the little kid came along, you were the number one thing. Every birthday was your birthday. Every dinner out was your dinner out. And then along comes another one. And all of a sudden, what are you? Who the hell cares? Does anybody say like, oh, can I see your oldest child? No. Oh, you got a baby! Right? And then some of your parents have the nerve to do it a second time and screw you over again. And sometimes that third kid is the only one of the other sex. So they get everything anyway. My mom had me. I had 21 months, apparently, when I was the king. I don't remember it, because I was only 21 months old. Then along comes my brother. He gets 5 years of being the king. And I'm thinking, yeah, this ain't so bad. I'll get used to it. Whatever. And then mom's like, we're having a baby. Oh, awesome. And then it was a frickin' girl. The only girl in the whole family. In that whole generation. So she was not just my parents' favorite. She was everybody's favorite. So who got screwed? Me. 21 months of being the king. Brother got 5 years. Sister, she's 40. She's still the queen. Anyways, I'm just kidding. Your little siblings are treasures to be cherished forever. Your lives are enriched because they have been brought into them. Huh? I'm 44. Oh, my sister is, yeah, no, she's not. My brother is 42. My sister is 37. That's better, yeah. She was born in 1982. Thank you. All right. Everybody good? Okay, listen to me. You are going to draw this graph. You are gonna draw it wrong. So draw it in pencil so I can fix it. Draw it with your neighbors, talk about it, describe how to do it, draw it. Go. What's going down here? Oh, what's going on the independent variable? Time, of course. And what's the dependent variable? Distance, of course. All right. In the first 2 hours of the trip, Jack leaves home and travels 140 kilometers at a constant speed. So, hour 1, hour 2. And he travels 140 kilometers. Let's go up by 20. Let's go up by, we'll go up by 50. So 50. So that's 150, right? So we got to almost go up to there. Since it's constant, it's a pretty straight line. Now in real life, would it be a straight line? Of course not. Why? Does Jack drive out of his driveway at 70 kilometers an hour? Does Jack drive through his neighborhood at 70 kilometers an hour? Of course not. But we'll say he did, okay? We'll say Jack lives right on the highway. Okay, Jack? Like, out there, vroom. All right, everybody cool? All right, so that's the first part. Let's change colors. Jack visits his grandma for an hour. What happens to the line? He visits his grandma for an hour. Stays flat. Why, Madeline? He's not going anywhere. He's sitting with grandma. They're watching Family Feud on Game Show Network or something like that. Right? What you do with grandma for 1 hour. Everybody cool? Now, here is where you're going to screw up. Where does the line go now? Which is it? Most of you will have drawn the blue line like this. Driving 50 kilometers back home and then stop for 30 minutes for supper, which is a flat line. That's what most of you did. Right? And then the last bit we'll do with a pink line. Returns home 2 more hours. Steeper or shallower than this? Steeper or shallower than the beginning? Shallower. Why? He's going less distance in the same amount of time. So that is what most of you drew, would be my guess. Am I correct? For most of you. All right. What you drew right here is what we call a displacement graph. What really should have happened is it should have gone like that. And that displacement graph, and that is what we call a distance graph. And let me explain to you what I mean, just in case you forget grade 10 science. I have to stand up to do this. How many directions are there in real life? 4? So I can only move at 90-degree angles? It'd take me a long time to get to Sci-Haj.
Infinity 360.
So, again, I ask, how many directions are there in real life? Infinite. Thank you. I could go up, down, left, right, diagonally. There's an infinite amount of directions, yes? How many directions are there in math? No. No. Oh my good God. What is math?
190.
What is math? The study of what?
Numbers.
How many directions can a number have? 2. Thank you, Madeline. What are the 2 directions a number can go? No. Good God, Harvey. No. 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 Thank you. Numbers can be negative or positive. That's it. No, it's not. Okay. I'm going to go up. What's that? That's not left and right. That's up.
Right is up, left is down.
Okay, so now you're at 4 directions.
Never mind.
Okay.
I'll give you this one.
You'll give me this one like you'll give me all the rest of them for the next 8 days as well, because you've yet to win one. You continue to try, and that's admirable. That is very admirable, Harvey. You should continue to try. All right, so math has only 2 directions, but we have to use those 2 directions to describe an infinite amount of motion, right? So, what math people have done is they have decided a bunch of stuff, and it's just decided that way. And this is where Harvey is indeed right. If you move to the right, you are considered to be moving in a positive direction. If you move up, you are considered to move in a positive direction. If you move north, you are considered to move in a positive direction. If you move east, you are considered to move in a positive direction. Everybody understand? Now, if all those are positive, what are the negatives? South, west, down, left. Everybody cool? Now, how does that help us if we're moving in a diagonal line? It doesn't. So what we do for that is we say if you are moving away from your starting point, you are gaining positive distance. When you return to your starting point, it is negative. Is everybody cool? You all should know this already from Science 10. Everybody's cool? All right, now, watch. From your point of view, tell me how far I moved and the direction I moved from your point of view. Everybody ready? You could say 3 steps left. What else could you say? -3, because I moved left. Everybody cool? Everybody cool? All right. I started over there, now I'm over here. I am -3 steps from where I started. From your point of view. From my point of view, what am I? Positive. Now, how could we reconcile those two? I have moved away from my spot, right? So we could both say positive for that as well, without a point of view. Is everybody cool? All right, now, count. Where am I? Because how far did I just move? 3 steps, negative, because I went back home, yes? Now, if you were blindfolded for that whole thing, and I wasn't wearing flip-flops, I was wearing ninja shoes, and I took your blindfold off, have I moved? No, I haven't, have I, Roger? I'm right where I started. But have I moved? Yes, how far did I move? 6 steps. Does everybody understand? All right. So what is happening here is as follows. Displacement is a vector. And what that means is it has a magnitude which is a size, and a direction. Up, down, east, west, left, right, away, towards, whatever. Everybody cool? Hey, Harv, how about you bring that phone up here so you can actually do something and win an argument for a change? You think I'm lying? Okay, so how about you bring that phone up here so you can pay attention and win an argument for a change? Thanks, brother. The other one is distance. And distance is a scalar. Because, wrong color, it only has magnitude or size. Your car's odometer, when somebody says, hey, what's the miles on your car? That is a distance. Because even if I drive my car to school and drive it home, my car counts that as 60 kilometers of driving. The one of you that has seen Ferris Bueller's Day Off knows that when you drive in reverse, your car does not lose mileage. Okay? You cannot drive around for 8 weeks backwards in hopes of rolling back the mileage on your car and trying to sell it for more money than it is worth, because you have spent every night for 6 months driving backwards around the block to lower your mileage. It does not work, because distance traveled is a scalar. It is a magnitude. I walked 6 steps. Even though I ended up back where I started, I passed through 6 steps of the universe. Does everybody understand? All right. Now, do I need to remind you of how displacement works, the positive negative thing? Or are we all good? Okay? All right. So, everybody understands why these graphs are different, yes? Displacement goes back home because I return home. Distance can't ever go downwards because I am traveling more and more distance even though I'm on my way back home. Everybody understand? All right. Go.